All right, welcome back for example 2. We're going to be doing the multiplication of scientific notation. So for problem A, we have 5.2 times 10 to the 12th times 3.9 times 10 to the 13th. Now, since all of these things are multiplied together, we can kind of change the order a little bit, and that's what we're going to do in order to multiply this. So the first thing I'm going to do is I'm going to multiply 5.2 times 3.9. Okay, so I'm going to group those two things together, and then I'm also going to multiply these because they have the same base. And when we multiply those together and they have the same base, do you guys remember what cheat rule that was? That was called the product rule, and we just add those exponents. Okay, so let's first multiply these numbers. I'm going to do that off to the side. 5.2 times 3.9. 9 times 2 is 18. Write the 8, carry the 1. 9 times 5 is 45 plus 1 is 46. And then add a 0. 3 times 2 is 6. 3 times 5 is 15. And we add, right? 8, 12. This is 9, and 1 is 10. Write the 0, carry the 1, and 1 plus 1 is 2. We have 2 decimal places here, so that means our decimal needs to go right there. So I should probably have wrote this. So we're going 5.2 times 3.9 times 10 to the 12th power times 10 to the 13th power, right? So this ends up being 20.28 times, and then we're doing that product rule. They have the same base, 10 to the 12 plus 13. All right, and then 12 plus 13, I'm just going to rewrite this, would be 25. Perfect. Now, this would appear as if it was in scientific notation, right? But there's a problem. Do you see what the problem is? Is this a number between 1 and 10? It is not a number between 1 and 10. So what do I have to do to this number to get it between 1 and 10? Well, to me, 20, it's bigger, so we have to make it smaller, right? So you can either multiply it by 10 or divide by 10. So what's going to make this number 20 smaller? Multiplying by 10 or dividing by 10? The answer would be dividing by 10. So I'm going to take this 20.28 and I'm going to divide it by 10. And what that's going to do is it's going to make this place value go one place value to the left, which would end up being 2.028, right? So we want to divide it by 10. However, whenever we're dealing with numbers, this needs to be whatever we have here. Once we divide it by 10, it needs to be the same number. So in order for it to be the same number, I can't just divide it by 10. I have to divide it by 1, but I'm writing 1 in a different format, right? So if I divide it by 10, I also have to multiply by 10 because 10 divided by 10 is 1, and I can multiply any number by 1, right? But what's happening, this 10, we're going to divide the 10, and that's going to be applied here. And then this 10 right here, the multiplied 10, that is going to be applied over here to this power. So let's see how this is done. So when we go 20.28 divided by 10, that moves that decimal place here, and we're left with 2.028 times this 10 times 10 to the 25th. Now we have the same base, right? And this exponent is a 1, so we can do the product rule. So we have 2.028 times 10 to the 1 plus 25, which ends up being 2.028 times 10 to the 1 plus 25 is 26. And that is our answer in scientific notation. All right. Let's go ahead and try this again with this problem right here. 1.1 times 10 to the 9th times 2.2 times 10 to the 3rd. Okay, so we're going to multiply them, right? So that means we're going to be multiplying these numbers together first. It's kind of like two parts. And then we have the same base with this 10. So we're going to multiply these powers of 10 together using the product rule. That's going to be our second part. Okay, let's go ahead and get started. So I'm going to take these two numbers and do the multiplication over here. So 2.2 times 1.1, that is a 1. 1 times 2 is 2. 1 times 2 is 2. We go to the 10, have to put a 0. 1 times 2 is 2. 1 times 2 is 2. We add 2 plus 2 is 4 and 2, and we have 2 decimal places. So that means we have 2 decimal places in our answer. So our answer ends up being 2.42 times 10 to the product rule. We have the same base, so we just add the exponents, and I want to see this work on your paper and quizzes and tests and all that. And then 2.42 times 10 to the 9 plus 3 is 12. And is this in scientific notation? The answer is yes, because this is a number between 1 and 10. So we are good. This is our answer. It's so nice when it's between 1 and 10. We don't have to do any extra stuff. So this was the right answer. All right, so now it is your turn to try C. So where's my friend? Here's my friend, the pause dragon. Remind you to pause your device. Go ahead and work out problem C. When you get done, press play and we'll talk about it together. All right, see you in a bit. Okay, let's see how you did. So the first part, right, is to multiply these numbers together. So we're going to go 4.5 times 3.7. 5 times 7 is 35. 7 times 4 is 28, plus 3 is 31. 3 times 5 is 15. Carry the 1. 3 times 4 is 12, plus 1 is 13. And then we add 5 plus 0 is 5. 1 plus 5 is 6. 3 plus 3 is 6. And 1. And how many decimal places? 1, 2. So that means we have 2 decimal places here. Oops, sorry about that. Okay, so that ends up being 16.65 times 10 to the 12 plus 8, right? We do that, 16.65 times, I'm going to kind of space it out here, 10 to the 12 plus 8 is 20. Now, is this number between 1 and 10? And the answer is no, it is not. So we are going to have to divide this number by 10, right? To make it smaller, move one place over, which would make it 1.665, and then that would be okay. But we can't just divide a number by 10. If we divide it, we have to multiply it by 10 as well, okay? So this 10 here, this divided by 10 is going to be applied to this number, and the multiplied by 10 is going to be applied over here, okay? So, all right, so I'm going to move this up over here. So when I divide this by 10, I end up with 1.665 times 10. Oh, times 10. Oh, I'm multiplying by 10 and then 10 to the 20th, right? This is 10 to the first. So I'm multiplying. That's going to be that product rule. So 1.665 times 10 to the 1 plus 20, which ends up being 1.665 times 10. 1 plus 20 is 21, 21st power. And there is our answer in scientific notation. All right, perfect. Now let's go ahead and look at some story problems. All right, so this says the mass of the sun is approximately 3.1 times 10 to the 6 times greater than the mass of Mars. Find the mass of the sun and then write your answer in scientific notation. Okay, perfect. So we have the mass of the sun. Okay, so mass of the sun. Mass of sun is, that means equals, this times greater. Okay, so 3.1 times 10 to the 6th power, greater than the mass of Mars, which is here. So the mass of sun is bigger than the mass of Mars. So the mass of the sun goes right here, and we're dividing it by the mass of Mars, which is 6.42 times 10 to the 23rd power. And this is the mass of Mars. So we're taking the mass of the sun and dividing it by the mass of Mars, right? Perfect. Okay, so it wants to know, find the mass of the sun. Okay, write your answer in scientific notation. So we need to figure this out. Right now, this is being divided by 6.42 times 10 to the 23rd. So if we need to figure this out, we need to use our algebra, right? This is being divided. We got to do the inverse operations, which would be to whatever this is being divided, we're going to be multiplying it by. So we're going to multiply this side of the equation by 6.42 times 10 to the 23rd power to both sides of the equation. 6.42 times 10 to the 23rd. So now we're multiplying here. These cancel out, and we're left with the mass of the sun. Okay, now we have this little multiplication, scientific notation multiplication problem. So we have to multiply these together first, right? So we're going to go over here to the side, 6.42 times 3.1. And I'm going to do the multiplication. 1 times 2 is 2. 1 times 4 is 4. 1 times 6 is 6. And then I go to the 10 spot, so I'm going to put a 0. 3 times 2 is 6. 3 times 4 is 12. Write the 2, carry the 1. 3 times 6 is 18, plus 1 is 19. And then I add, okay, 2, 4 plus 6 is 0, 10. That's 8, 9, 9, 1. And then how many decimal places? 1, 2, 3. So 1, 2, 3 right here. Okay. So this ends up being 19.902 times 10 to the 6 plus 23, right? And we end up with 19.902. I'm going to make a times here, times 10 to the, what would that be? 6 plus 20, 29. Okay, perfect. So this is our scientific notation. The question is this number right? Is this a number between 1 and 10? And the answer is no, it is not. So we need to make this number bigger or smaller. Well, it's bigger than 10, right? It's 19, so we need to make it smaller. So do we make it smaller by multiplying by 10 or dividing by 10? Well, we make it smaller by dividing by 10. So we're going to have to multiply this and divide by 10. But if we divide by 10, we must also multiply by 10 because 10 divided by 10 is 1, and we can do that, right? So then we're going to divide this portion of the number by 10. And then this multiply by 10, which is right here, we're going to multiply that power by 10. Okay, let's do it. So I'm going to go up here. So 19.902 divided by 10, that means that decimal place over 1. It's going to be 1.9902 times 10 to the, right, this is a 1, so we're going to be doing that product rule, 1 plus 29, or 1.9902 times 10 to the 30th power. That would be our answer. Perfect. Okay, so we're going to do E, and I want to give you a chance to try E on your own, okay? So I'm going to give you a little time now. Here's my friend the Pause Dragon. Remind you to pause your device. Go ahead and work this out. When you get done, press play, and we'll go over it together. All right, see you in a bit. Okay, let's see how you did. So we have the mass of Venus is 4.87 times 10 to the 24th kilograms, is about 66 times the mass of the moon. What is the mass of the moon? Write your answer in scientific notation. Okay, great. So what do we know is bigger? We know the mass of, we know that the Venus is bigger than the moon, so that's going to go on top. The mass of Venus, so we have 4.87 times 10 to the 24th is equals 66. Okay, and then the mass of the moon. So we're going to divide this by the mass of the moon. Okay, and we need to determine what is the mass of the moon. Well, to get mass of the moon, right now it's on the bottom of the fraction, and we need to get it to the top. So that means I'm going to multiply both sides by mass of the moon, right? This is the division, so we have to do the inverse operation of division, which would be multiplication. Mass of moon to both sides. And then what happens? Those cancel. We're left with 4.87 times 10 to the 24th equals 66 times mass of moon. Okay, now we need to get mass of moon by itself, so we have to get rid of this. This is 66 times, so we're going to have to do the inverse operations, which would be division. So we're going to divide by 66. Okay, so let's go ahead. I'm just going to use my calculator for this. 4.87 divided by 66. 4.87 divided by 66, right? And that ends up being, what do we know? We know that the 66 and the 66, that's 1, so it cancels each other out. And then it says 4.87 divided by 66 ends up being 0.0737, and we'll round that up to 9. Times, okay, so that's 4.87 divided by 66 times 10 to the 24th. So there is no power of 10, so we just rewrite that. Okay, now the question is this a number in, and this equals the mass of the moon, right? Mass of moon. Is this number between 1 and 10? And the answer is no, it's way too small, right? So how many times do we have to multiply by 10 in order to get this to be a number between 1 and 10? So, like, let's see here. If I was to move this over, that would be like multiplying it once by 10, right? But it would be 0.73. It still wouldn't be big enough. So I'm going to have to multiply it by 10 again, and then I'd have 7.379, which is a number that is between 1 and 10. So let's see how this works out. So I'm going to have 0.07379, and I'm going to have to multiply it by 10, and then multiply it by 10 again, right? That's 10, and then that's 10 again. Times 10 to the 24th. Now, I just can't do this. If I do this, I have to also divide by 10 and then divide by 10 here as well. Okay, and those are multiplied by each other. So, now this part, remember, this part on top is going to go here. And the part on the bottom, the dividing by 10 and the dividing by 10, this dividing by 10 is going to go over here to the power. All right, so let's see how that works out. So when we multiply it by 10, it moves over one place. Multiply it 10 again, it's right there. So we end up with 7.379 times 10 to the 24th power divided by 10 times 10 is the same thing as 10 squared. So now we have the same bases and its division, so we're going to do that quotient rule. 7.379 times 10 to the 24 minus 2. We subtract the exponents, and we're left with 7.379 times 10, 22. 24 minus 2 is 22. And this is the mass of the moon. So if you got that one right, you did a wonderful job, and I will see you for the next lesson.